Really, the last topic we have here are the derivatives of sine and cosine. In order to find the derivatives of sine and cosine, we're first going to need to know a couple limits. So one of them is the limit as x approaches 0 of sine of x over x is equal to 1. And the limit as x approaches 0 of cosine of x minus 1 all over x, and this is equal to 0. So we're not actually going to prove these two limits here right now, but I do have two other videos on Canvas that you can look at in order to understand why that first limit's equal to 1 and the second one's equal to 0. So let's go ahead and see what the derivatives are, and then we'll prove it. Okay. So the derivative of sine of x is cosine of x, and the derivative of cosine of x is minus sine of x. All right, let's show that the derivative of sine of x is equal to cosine of x. We'll have sine of x plus h minus sine of x, and then this is all over h. And I'm going to continue working on this line right here because I didn't give us very much room to do this. So the limit as h goes to 0, and then I can rewrite this as sine of x cosine of h. And by this, I want to point out this right here, we're going to use a trig identity on it. And so this is sine of x cosine of h plus cosine of x sine of h. And then we still have that minus sine of x. And all over h. And so that first highlighted portion that I have here is equivalent to this highlighted portion. And again, we're just using a trig identity here. All right, and so I'm going to try and do a couple steps here. So I'm going to actually bring together these two terms that have the signs. So sine of x cosine of h minus sine of x, and then all over h. And then we don't want to forget about these other ones, plus cosine of x sine of h, and then this is all over h. All right, and then we have the limit of a sum. Okay, so instead we're going to look at each one of those parts of the sum and take the limit of them separately. Okay. And we're going to do a little bit of factoring in the process here as well. So note that sine of x in itself, just sine of x, there's no h's in it, right? So you can actually bring that out front of one of these limits. And if you were to factor a sine of x out of here, you're going to be left with a cosine of h minus 1, and then this is all over h. And so this might look familiar. We know that this is going to go to 0 here, and then plus, and again, I can pull this cosine of x out front, and then we're looking at the limit as h approaches 0, and we have sine of h over h. Okay, and we know that this limit's 1. So we end up with 0 here, right, because of the limit as h goes to 0 of cosine of h minus 1 over h. But that second limit, since it goes to 1, we get, right, plus cosine of x times 1. And so this is just cosine of x. All right, now let's actually use this formula now. Let's do an example. All right, let's go ahead and try and use our new derivative. Okay. We know that if f is equal to sine of x, then its derivative is just cosine of x. And we want to find the tangent line that goes through the curve at x equals 5 pi over 6. And remember, instead of m here in our point slope form, we actually use the derivative. So f prime of x1 and then times x minus x1. Okay. Again, that's just our slope. Okay. So if we want to find the slope of that tangent line, we're going to have to plug in 5 pi over 6. Which is minus the square root of 3 over 2. All right, now that we have our slope of our tangent line here, let's actually find this point y1 here. So keep in mind, our tangent line, right, we know the x value that we're concerned with. Well, if I just want to find the y value, I just need to plug it into the function. All right, f of x will give me the y value. So if we do f, and I'm actually, all right, this is our slope, and this is our y1, f of 5 pi over 6. So this is just sine of 5 pi over 6, which is 1/2. So we get over here, what, y minus 1/2 is equal to minus the square root of 3 over 2 times x minus x1, which is 5 pi over 6. All right, and we can leave this just like this, or if we want to solve for y, we can solve for y. I'm going to choose to go ahead and just leave it like this.